Tonight's video is part 3 of section 5.2 on the integration of natural logarithms. The homework will be out of 5.2, 47 through 64 all. So the directions for the first section will be just to evaluate, instead of indefinite, which is the plus c, definite integrals in which there'll be an upper and lower bound. So again, let's just review some of these things we need to remember before we do one of these problems. The natural log of 1. Remember, with natural log, all these have a base of e. So e to what power is 1? That's 0. So e to what power equals e? That's 1. E to what power is e squared, right? So e squared is e squared. E to the first power is e to the first power. E to the 0 is 1. And so 1/2 times natural log of x, remember I can rewrite that as natural log, and I bring the 1/2 to the x, which really means square root of x. And natural log of 3 is a numeric answer. I could put that in my calculator and get some decimal approximation. Just as this has an answer and this has an answer, this does not, right? These all have answers. But just remember that this is also a numeric answer like these are. So let's start with number 49. I will work out a couple of examples directly out of your homework. So again, it just says to evaluate this definite integral. It's not an indefinite with your plus c. So I'm going to go ahead and let u equal the numerator, which is within the parentheses. And the reason I'm going to do that is because I know when I take the derivative, that's going to go away, and this is going to be 1 over x, and I'm going to be able to take care of that 1 over x. du equals 1 over x dx. And so what do I have? The numerator is u squared, and it takes care of that 1 over x dx. I can replace that with du. So now I can go ahead and I can evaluate that. When I do integration, I increase it by 3, divide it by 3, which is 1/3, and that's from e to 1. Except I need to go ahead and replace that u first, and that's 1 plus natural log of x, and that's to the 3rd power, right, from e to 1. So what is that? 1/3. So I'm going to put a square bracket and put a parenthesis so I can put in e first. 1 plus natural log of e cubed minus 1 plus natural log 1, right? So let's take a look at this. Natural log of e. So e to what power is e? That's 1. That's really 1 plus 1 cubed. And e to what power is 1? 0. So that's 1 plus 1, that's 2. That's 2 cubed. 2 cubed is 8. And that's 1. 1 cubed is 1. So that's 7. 7/3. Done. Next problem. I have 52. So this one here, if I let u be the numerator or denominator, then when I take the derivative, how am I going to get rid of that other half, right? If I make it equal to the denominator, how do I get rid of that x minus 1 in my u? Because I know with my u, when I take my derivative, it decreases the power. You know, if this was squared, I might have some more hope, but it's not. So what do? Well, I'm just going to let u be equal to the denominator, which is what I usually do, right? So far, what do I have? I have this being u, but I have all these items still. In fact, my dx is du, sorry. But I still have this x. That means I have to take this and rewrite it. So u minus 1 equals x. So there's that x. I'm going to replace it with u minus 1. U minus 1 minus 1 which is really u minus 2 over u, which is u over u minus 2 over u du, which this is, that's 1, right? 1, so that's really just a du. Cut out my 2, right? So this was 1 times du minus, I'm just giving each one its own integration. Took out the 2 and it's 1 over u, correct? So now let's follow through with this. This would just be u from 1 to 0. 2 times, and this is natural log of absolute value of u, from 1 to 0. Let's substitute in my u. My u was x plus 1 from 1 to 0. So really it's this whole thing of from 1 to 0. So that's 1 plus 1 minus 0 plus 1 minus, I'm here now, right? But the 2 on the outside, natural log 1 plus 1, minus natural log of 0 plus 1. Let's see, so what is that? 2 minus 1, that's all of this. Right, there's that minus. Natural log of 2 minus natural log of 1. That's 1 minus, well, e to what power is 1? That's just 0. So this is really 2 times natural log of 1 minus 2 natural log of 2. Oh, there it is. I'm sorry, let's just take a look at my notes. And then this power, this can be raised to the power. Done. (55 through 60) ask you to evaluate the definite integral in the graphing calculator. So please follow through and do that and practice using your graphing calculator again. Then from 61 to 64, it says find f prime of x. So for example, they give you, like in 61, this f of x equals this integration. So it's kind of like when you take this and you integrate, you go back to the original. Once I get the original, then I go and I take the derivative and I go back up here, right? Because isn't this the derivative of this? So this is where I'm going to use the second fundamental theorem of calculus, that circular argument. And there was a trick on how to do this. And so the trick in finding the first derivative is I take this function and I input whatever the upper bound is. And it times it by the derivative of the upper bound. Done. So again, let me talk about that again. The second fundamental theorem of calculus. That's that circular argument that here's a function, and when I integrate it, I'm going backwards to the original function. But if I want to go and take the first derivative, I'm going to go and I'm going to take its derivative. I'm going to go back to this. So it's circular. So the trick to find the first derivative is I take this function, and wherever the variable is, I put in the upper bound. Then I times it by the derivative of whatever the upper bound is. And the derivative of just x is 1. Done. That's it. Thank you.